All right. Thank you, everybody. This is the Microsoft Data Platform Continuity Virtual Group for our June 2026 session. With me again is Thomas T.G. Grohser. We're going to be doing our infamous icosahedron, our truncated icosahedron table. This is season 2, episode 5. And we're going to take a bit of a detour today and talk about the history of SQL Server. And quite frankly, there's very few people on the planet qualified to talk more about this than TG here. So with that, I'll turn that over to you, TG.
Hello. Thank you. Thank you very much. So, yeah, for the qualified person, due to my own research, I think I'm the second oldest person to work with SQL Server. So, I work with SQL Server 31 years now, going on to 32 years. And there's this one guy called Bob Ward who is 32 years. Yeah. And the only reason is he started with SQL Server before it was running on Windows. I literally started with 4.21a, which is the first version running on Windows in 1994. Yeah, and yes, this was before Windows 95, so the client software was still 16-bit at the time.
Yeah, my
And
first my first version was
in
6.5 in late 98, I believe.
yeah, yeah, that this was like 32-bit were already done. But
Decadence.
there's an explanation while when you look at the protocol, how SQL Server transfers data, that when you read a blob, an in-text max or some of these, why you get 64K at a time and not more. Because when SQL was developed, the clients could only read 64 kilobytes at a time because the CPU could only address 64K in one go. So all the data transfer had to be broken up into 64K chunks. And the sad part is it's now 32 years later and that stuff is still in there. Um, so could you make data exchange with SQL more efficient by breaking that? Yes. Would it break some 32-year-old software? Yes. So it's interesting. So yeah, so I spent the last 2 weeks or so, not the whole time, but whenever I had like nothing else to do, with thinking about the history and together. So I came up with the idea of doing it in three angles. One, a generic history about record keeping, and then the official SQL Server history, and then the SQL Server history from my perspective. So how I saw it, like, and I have come up with each and every version with the best and the worst feature that Microsoft released in every version, except for 2025, because I still believe the verdict is not there yet. I have too many potential candidates for both categories. So the English, but for all the other versions, I had it down to one, sometimes two best or worst features, because sometimes you can't like figure out which one it is. They are both absolutely horrible or thing is. And sometimes it's not so much a feature, but you will see. Yeah. So for the record keeping, the oldest reference of humans keeping records is about 5,200 years ago. A bunch of people called Sumerians, we know them now as Iraqis, not Iran, Iraq, the other guy, the ones a couple of years ago. Uh, they used tablets made out of clay, not iPads, tablets made out of clay, like stones, and wet clay, and they used like little sticks to carve information about how much livestock and grain deliveries were uh, sent to the higher ups in the country. So that's interesting. Um, 700 years later, similar stuff were found done by the Egyptians, but they'd used papyrus already, so the predecessor of paper, which came 1,900 years ago, so a couple of hundred years into modern timekeeping. Um, um, and from there, it went crazy. I mean, we can't all imagine that the first databases were actually warehouses filled with paper, and not having an index back then meant you're going to crawl through that warehouse for days to find something. So the people that were keeping these records, they were highly appreciated in the companies because if you did not play nice with them, they could make you wait for days and weeks to get your data. But that shows how some of the names that we're using today, like data warehouse, they were literally warehouses filled with data. It's just we kept the name, but nowadays it's a database in some product that has probably a bazillion more times of information in it than back then the paper had. But as we can see from that, humans always had this absolute desire to manage and keep records. This is like since we find history, and I'm pretty sure there's older stuff in some caves somewhere where they were counting stuff and writing it down, but it is. In the 1950s, so 70 years ago, 75 years, 76 years ago, computers became a thing. I mean, the first computers were still, the data was still on paper. It was punch cards the computers were reading, then replaced by magnetic tapes. And there's books written about the topic of how you sort data on a magnetic tape because the only way you can access it is sequential. And when you, so how many tapes do you need to sort like a tape of sequential information, like by a certain key or something? And how how many times do you need to copy the data from one tape to another back and forth? And there were books written of how you optimize these uh, algorithms because even today, when you write to a hard drive, the hard drive tries to optimize your writes by sorting and grouping them together and stuff like this. But this is done to save microseconds. On the tapes, if you could avoid one tape swap, you made your sort faster by an hour. And we're talking that it could take like 60, 80 tape swaps to sort something. Because the ideal situation was you had three tapes at the same time and you could move data from one to each other, but that was rare. Most people only had like one tape drive, so you had to read something in the little memory you had and then swap the tape and write it to the other tape and then swap back and read the next record and moving on like this. So funny. Luckily, in 1957, someone at IBM invented the hard drive. And the name hard drive became from it because about 4 years earlier, they invented like the floppy disk, which was very floppy and soft. And the hard drive was a metal platter instead of a magnetic, like the floppy disk is basically a tape in form of a disk. But the hard drive then made the disk so stable that you can run it much faster. And that pretty much opened the door for all the little things that we have and we store today. What we're trying to store is all kinds of data, quantitative data, qualitative data, all these kinds of little things that are defined, and you can use the interwebs to figure out what the difference between quantitative and qualitative is. The short term is quantitative, you can measure it. Qualitative, you can observe it. Qualitative is like a color. You can observe it, you can technically these days you can measure color, but it's still you're comparing it to something else. Measuring is yes, this thing is 5 inches long, or this has 27 pounds of weight, or the temperature is 69 degrees Celsius, or something. Yeah. Um, oh, this is good. I often get asked what enterprise data is, and my answer is always 42, because the number 42 perfectly explains what enterprise data is. The difference between data and enterprise data is that enterprise data is defined what it means. Because if more than one person uses data, you have to figure out and define what the data is. And this is the hardest thing in databases to do because in the beginning, databases allowed you to use 8 characters for their column names and table names, which was not that much. So putting a good descriptive name in there was really hard. But why 42 to explain enterprise data? Mainly because there's a website that has over 700 meanings of the number 42. We all know the most important one from Hitchhiker's Guide to the Galaxy, but I give you a few others. 42 is the European shoe size that I had when I was 16 years old. I grew a little bit more, so now they're bigger, but back then it was 42 and not like that would be like a 9.5, 10 in the US. 42 is also 6 times 9 if you're using a numbering system that has a base of 13 instead of 10. Uh, um, Queen Victoria had 42 grandchildren, if you're still in the old country. 42 kilometers per hour was the speed at which the Titanic hit the iceberg. So that's a good 42. It's the name of Buzz Lightyear's spaceship in Toy Story. And it's also the angle in degrees at which light has to hit water to create a rainbow. So 42 is the answer to life, the universe, and everything. And the whole part of this funny story is that you need to understand what data means and you have to document it so that everybody else that uses the data also understands that. Yeah? And for example, how to name a column. A very bad name would be the letter L. A bad thing, not very bad, but still bad, would be length. Yeah, I want to store the length of something. A good one would be length in inches or length in centimeters or length in miles or whatever. So defined it. Excellent would be cable length in inches. Yeah, because you define what's the length for. Yeah, thing is. A little bit overboard would be cable length in meters, excluding the connectors measured at 68 degrees in Fahrenheit. That would be overboard. But don't get me wrong, the overboard version is what should go into documentation.
Data dictionary content right there.
Exactly. Yeah. Because as every person who didn't sleep through physics in high school knows that with temperature, the length of object changes. So if you wanted things precise, you actually maybe for the length of a cable, it doesn't matter if it's an inch or an inch 0.001 or something. But if you, I don't know, catalog the little gears that go into a Swiss watch that is sold for a couple of millions, you might want to be very precise and measure the right thing. Yeah? And other examples are C for capacity, very bad. Capacity in gigabytes, a little bit better. Hard disk capacity in gigabyte or storage capacity in gigabyte, yeah, that's okay. Overboard is hard disk capacity in gigabytes with gigabyte defined as 1024 times 1024 times 1024 bytes. Yeah. If you use that as your column name, I will fire you. But again, that is the one that goes into the documentation because if you store it in gigabyte, you need to know that's not a billion. You need to know that's a little bit more than a billion. Yeah. And this is so on. Yeah. The next thing is over the years, we want to compromise between easy to use and fast. So we came up with we can store data in plain text. It's called big data. You put it in text files and you dump it somewhere. Yeah? Okay. The problem is if it's just plain text and you have 10 different people creating the documents, each one will look different and you need a very, very intelligent parser. And don't tell me AI can do that. Yes, but consider the cost. If you have to process every text file every time you read it by AI, your company will be bankrupt soon. Um, and then you could use some markup language where you have like some control structures over it, or you have well-defined markup languages like XML or JSON, where it's a very defined, it's almost like a schema, but it's still super flexible. Is it still human readable? Questionable. Um, JSON better than XML, HTML or some other markup better than both of them, plain text or like document text better. And then on the other end of the spectrum, you have relational databases. That's what we are in the end talking about here. They are structured. They are very structured. Can you put stupid XML files in a relational database? Yes, you can. Should you do it? No. Wait till my most hated feature of SQL 2000. um, things. So you have to find things. Yeah? Plain text, it's super easy to gather the information, to have it, to store it. Thing is, but every time you need to analyze the data, you're spending a lot of energy and computing cycles to do so. And you have to understand that in most cases, you collect the data once, you process it once, but you read it thousands of times if you do it right. Yeah? So taking the time and making it structured data, where you can then find it very quickly and very efficiently, will pay off in the long run. And this brings us to the big data, which is the last kind of data I'm going to talk about before going back to the history, is there's so many definitions what big data is. The ones I laugh mostly is the three V's that are by now are 10 different words that start with the letter V and define big data. Volume, variety, velocity, value, veracity, uh, validity, vulnerability, volatility, visualization, and value. None of them has anything to do with big data, in my opinion. Again, my opinion is shared by very few people, but hey, there's not many successful people here. Uh, Big data is technology that can process not yet understood data. That's my definition. So big data tools, you can point them on any kind of pile of data you have, and it helps you make sense out of it. It costs a fortune to do so on compute, on storage, on everything. Once you understand the data, you process it and you put it in a relational model, and then you start using it repeatedly from there. You cannot use big data repeatedly. Big data is for one-time use or a couple of times use. You collect it, then you find the information that you're looking for, and once you have it, you extract it and use it efficiently. If you're not doing this, you will over time collapse. Yeah. I have this example. I worked for an poker company, online poker, and we had these 250 terabyte history table of every poker game ever played. And we had it in a SQL Server database in a partition table. This was before column store, so it was a gigantic table, 250 terabytes, and we're talking the year 2010. So nice thing. And if we needed one poker game, the information for one poker game, it took SQL Server 3 or 4 milliseconds to find that in that data because we had indexes on everything that we needed and we could find every game, every player, the information super quick. Problem is, if we tried to find a pattern, it took SQL Server several hours to read the data. So we also had a Hadoop database with 64 nodes, 64 compute nodes Hadoop for the 250 terabytes back then. And it had the exact same data, no difference. And the Hadoop system, if we needed to process and find a pattern, it took about half an hour. So way better than the SQL version. Problem is, if we needed a single game, it took half an hour. Because the only way Hadoop could process the data is by reading it all. And each node took its 64th of the 250 terabytes and parse through it every time we needed it. Yeah. So use case for both sides. Thing is, so this is my take on on big data. The important thing is that whatever you do is you have to use the right tool. And we all know that because Scotty told us this in Star Trek many years ago. I think it was in the fourth movie. I want to share my screen. And I hope it's this one. We'll see. You should see a picture with hundreds of tiny little uh, product names on it.
Yep, looks
Yep.
good.
Okay. So this is the database landscape in 2017. And that's why you have to see this. Yeah, that's the one in 2025. You can't read it anymore. It's about 6 or 7 pages right now if you want it in a readable form. And I'm 100% convinced this is not even close to everything that's out there. Yeah. And the problem is, at that growth rate, nobody can keep up. You can't learn all the things that existed in 2017 in any form. Yeah. And just to give you an idea, I once found SQL Server on that thing. Yeah, it's a tiny little sliver. Yeah? There's an Oracle somewhere here, but there's Oracle, but it says a NoSQL database. I don't know why Oracle is listed there. Probably they have something in the engine that this thing is, uh, but it's insane. Yeah, so this data landscape is getting out of hand. Yeah. And there's more and more products for every type of time series, document store, white column stores, graph databases. And the reason all this stuff exists is, hello, I want to stop sharing. Don't run away. The button, when I tried to click it, moved. um, so the reason all this specialized engine exists is because relational databases exist for like 50 years now. But the problem is they aren't generic. So you can solve every problem. But some problems you cannot solve in the best possible way. So certain people that had a problem where a relational database showed signs that it would not be able to handle the workload if they keep growing the way they're growing. So they started developing their own specialized engines. Yeah. And that's great because they created something to solve their individual problem. Problem is, then other people saw that product and says, "Hey, I want to use that too," but your use case is very different. My prime example is always Cassandra. Cassandra was developed by Facebook to handle the messages you post in Facebook, and they had to deal with billions of these messages every day. So the system needed to scale for writes and scale for reads because billions of people wrote messages and billions of people read the messages. But they had they made one decision. An individual message is not important. The majority of the messages need to be saved. So if an individual message cannot be saved for whatever reason, that's perfectly fine. So the engine, the Cassandra engine, and that's documented on their website, at any point in time can choose to not commit a write and just ignore it. And it does that. And again, if you have a messaging system for billions of people, that's perfectly fine. Worst case scenario, someone sees the message doesn't show up on their page and they post it again. Might even be that the client, if he couldn't read it back or something, then posted it again. But you as the client had to make sure to do that because the database itself would not tell you that it didn't read that. And a relational database like SQL Server would never do that. They either commit it to you and then it's in the database or not. There's no in between. And that's a special case. So for that use case, Cassandra is perfect. Would I use it if I had to make a decision for Facebook? Yes, probably. Maybe not today. They probably moved on and went to something even bigger, but made total sense. Would I use it in a financial company to deal with financial records? Hell no. Yeah. Yes. And that's the same thing with everything else. Key value stores. Is SQL the most efficient way to store key values? No, because if you have the keys are long strings, SQL is not good in finding long strings, even with indexes. It's not super efficient in it, especially if you're looking for parts in the middle of the string. Yeah. Anyways. So yes, if all you need is key values, it's fine. But if you need key values and then need to join a couple of these key value things together, most key value stores fail miserably because they're not built to do that. So you as a developer now start doing a relational engine on top of a key value store. And there's a reason Microsoft hires thousands of people and Oracle hires thousands of people to develop these relational engines because it's not easy. It takes a while. So yeah, all these engines are great. What Microsoft choose is to put extra engines inside the relational engine. So for years, we only had the relational engine, Pro Store, as we call it today. And then we added in-memory OLTP. We added column store. We added, it was not in the engine, but we tucked it on analysis services. Yeah? All this stuff, graph database came many years later. Yeah? So all these things to make it easier for developers to use if they have a specialized case. There's still no key value engine inside of SQL because usually a good clustered index is good enough. So, enough rant about what data is. Let's go to the history of databases. Share this thing again. So, a long time ago on a computer far, far away. So, the history of databases. It all started basically in 1951 with the invention of the magnetic tape. We already talked about it. Sequential storage only. Magnetic disk came in 55. And then 1957, the hard drive with real random access at a reasonable speed and capacity. So that's good. And then from there, it blew off. The first index was invented in 1962. I was still not born for another 8 years. Uh, the first databases, ISM databases, index sequential access databases came up. And all kinds of weird things because at the beginning, basically every application came up with their own data store and used it somehow. Till at some point, companies figured out, hey, what if we make a data store and then let other developers use that? And in 1970, a guy called Edgar F. Codd wrote 2 papers. Quickly unshare and do something because why is this thing always running away from me? So you can't see much here, but
Upside down.
other way around.
Holy cow. How'd you find that?
I collect books. So the word paper is a little bit misleading.
That's
That
dense.
paper basically defined relational theory used for databases, the relational model. That's the first. It's version 2. I don't have version 1, but it's out there somewhere. But this is from the 1960s or 1970s. Yeah, it's interesting. I tried to read it. Can I understand it? No. Do I understand databases? Yes. Luckily, there was another dude called, again, wrong side up, called Date. He rewrote all this stuff then in much more database oriented thing because he basically took these papers and rewrote them into SQL. Uh, um, and these two books together basically became the first databases, System R, the first relational database, and then very quickly after that, Oracle. Um, and then actually DBase was after Oracle, which is hilarious. And it took years for DBase to actually get a SQL interface. Uh, yeah, when you research this stuff, you find out that things you thought were not that accurate. So moving on, coming to the year 1981, which is another very important book. A guy called Jim Gray wrote this book, a little bit bigger than the other ones.
It's come on, night reading. You do that before you go to bed, right?
This is basically the documentation of SQL Server source code. He wrote it just before SQL Server was invented. So basically, he wrote how a database should work. And you find indexes, clustered indexes in it. You find clustering defined. All the stuff that SQL Server has is basically in there. Yes, Microsoft hired Jim Gray at a later point in time. And um, most of you guys will probably more remember David DeWitt, Dr. DeWitt, who did many keynotes at Past Summit. Jim Gray was his predecessor till he died in a boat accident on the ocean. So he went out for a sail and never came back. They found the sailboat, didn't find him. So he basically wrote, this is how SQL Server should look like when it ever gets built. A very interesting book to read. If you understand SQL, you can actually understand what's going on in here. So let me go back to, do I have more books? No, the other ones are for much later. So let me click back on share. So Jim Gray in 1981 wrote basically this book that was thing is, and that became Sybase and later on SQL Server in 1989. In between, there were little things like DB2 from IBM, Fox Pro, RDB, which was digital deck, digital database. They merged with Oracle at some point. Informix, also one of the very early ones, still in business. And Postgres with a S at the end without the QL, which is the predecessor of today's Postgres SQL. Thing is, so 1989 SQL was born. I gave it a yellow background to emphasize it. Later came XS. So XS came after SQL. MySQL came way later. Sybase at some point between 98 and somewhere around 93 or so gave up on their version of SQL Server and started Sybase ASE, which stands for Adaptive Server Enterprise, which is still a product today and is still used by some financial companies because they have software that's 30 years old and nobody wants to rewrite it. So let's keep it running. 1996, Postgres became Postgres SQL. The 2000s were all about big data. Hadoop, Vertica, MapReduce, Bigtable, Dynamo, Cassandra, all this stuff was invented. There was like a database every other week that showed up somewhere and solved the problem that someone had. 2006, very important, EC2 which is Amazon Web Services, came along, changed a lot. 2010, Asia was born. Unbelievable that this thing is 16 years old now. Um, DynamoDB, Neo4j, MariaDB, which is MySQL, but without the licensing fees to Oracle. CockroachDB, so the name's getting weirder and weirder. Thing is ClickHouse, very good column store database. Cosmos DB, not that old. So 2021 DuckDB. Yeah, the more current years, I don't know which products will be successful, so I will fill this out in like 10 years. DuckDB is just for the name. I find it hilarious. So moving on to the history of SQL Server. So the most important history is how did the logo change over the years? We went from a very colorful logo that was gray and red, and I don't know if anybody's listening that even remembers, there was a product called Microsoft Back Office, which was Exchange, SQL, web server, and a bunch of other things bundled together at a reasonable price, as long as you ran them all on the same server.
I ran that at two different companies when I was in college. It worked well.
They even had then a small business version of it
Hmm.
that was even cheaper, but was limited to 50 users. And thing is, and back office used these snake kind of woven lines because each line represented one of the products, and that's how SQL got the logo. Then they came up with that bent mesh, which was very, very long. And then once Fabric came along, we needed a logo that looked more like the Fabric style logo. So SQL became a new logo in 2022, I think. They started changing it, and 2025 made it more or less official. So we're basically on the third logo over a period of 30 years. So logo for 10 years. Yes, I know a person that has this tattooed on his forearm. He is going to be pissed about this. Everybody told him you can't trust Microsoft's marketing. One day this will happen.
Which one did he have tattooed on?
The middle one
Oh, okay.
on his arm somewhere.
Do
It
I know? Do I know this person?
probably.
Wow.
He's from down under. So
Yep.
yep. Dang it. So as I said, the official birth date of SQL Server, as far as Microsoft is concerned, is June 12th, 1988. That's the day they signed the contract with Sybase. With Ashton Tate and Sybase to create Sybase SQL Server for IBM OS2, which was released as SQL 1.0. Philippi was the code name. And this thing was still 16-bit database. Again, at the time, most CPUs were only 16-bit, so had to happen. Sorry, need my mouse pad. In 1993, Microsoft released 1990 SQL 1.1 and 1992 SQL 4.28. There was no SQL 2.0 or 3.0 or something like this. And then there was a 4.2b. So I'm guessing that was the very early version of like a service pack or something. Back then, patching was not a thing. And they were all just running on OS2, on IBM's operating system. And in 1993, Microsoft released 4.21a. I don't know if there's a 4.21 that never worked or something. The first release is 4.21a. And let's stop sharing again. And this is the installation CD from that version of SQL Server. So, yeah, 30 years old, still works. I mean, you need a very old version of Windows to install it, but thanks to VMware, you can get that running without a problem. Sharing again. So, the code name of that version of SQL Server was SQL NT. How creative. But okay. And it was 32-bit. So that was a huge thing. I mean, the 32 bits were useful because back then the typical, so my first SQL Server had 8 megabytes of RAM. It was a 386 and the run book was whoever comes into the office first. Doesn't matter if it was the cleaning lady, a developer, the receptionist, the CEO, whoever came in first in the morning, pressed the button to turn on the server because it took about 45 minutes for Windows to boot and load SQL Server so you could actually send requests to the database. So yeah, 45 minutes, but hey, it was a server. So just to be clear, I had a 486 as my desktop, but so it was not the best machine you could get at the time. But again, for development, we were a small company and that was all we could afford. I guess. These 4 pictures are courtesy of Bob Ward. These are like pre SQL versions 4.2. This is a picture of the original manual, and again, some very early CD-ROM. I asked him if he has any old stuff, and he sent me these pictures. So thanks for him. I guess. Speaking of these handbooks, since I am a book hoarder, here is the SQL 4.21 T-SQL reference manual in English. And since Microsoft back in the days, I lived in Austria, they also provided a German translation of the book, which shows you how much longer German is. You need about half an inch more book. It's exactly the same content, just translated, but it needs more space. Uh, if you ever wonder why there's so much space in between all the icons in some products, is because you have to take care of other languages. Thing is, so 4.21 was good for about 2 years, and then in 1995, SQL 6.0, codename SQL 95, because they started to implement the SQL 95 standard that was around. It will take them another 10 years to finish that project, but they started implementing it. And it was the first one designed for Windows. Yeah, because I mean, 4.21a was like, how can we make it run on Windows without breaking too much? I mean, 4.21a didn't have a log file. There was no log file for the transaction log. The log was a table inside the database. So you log to your data files. Interesting concept. Let me put it this way. SQL 4.21a was for sure not really 100% guaranteed data loss free. But in SQL Server 6.0 and 7.6.5, they started going there and they started to pick up a cadence like 1 release per year, which was good. But they very quickly realized that, hey, this is based on Sybase code, because they just took the Sybase code and rewrote it so that it ran better on Windows. But they found some design flaws that they didn't like. Yeah. 6.5, by the way, was the first version you could cluster So failover clustering was possible with SQL 6.5. It has nothing to do with what we know about failover clustering today. So I am 100% convinced that 6.5 failover clustering, your availability was way lower than running a single machine. Might still be the case today, but back then it was guaranteed. The problem of the number of problems you had, the first cluster I built didn't have a RAID for the drives because you couldn't cluster a RAID array yet. So you could only cluster individual SCSI drives. And the problem was, so you had to have a RAID controller in each of the two servers. The problem is normal Windows could not deal with that there was another RAID controller on the bus. So what you had to do is you had to install the cluster-aware drivers that didn't come with Windows in a later product because the add-on product had the awesome code name Wolfpack. It was the cluster service on top of Windows. And there's a great t-shirt, Wolfpack, the friendliest software on earth. And underneath is a pack of wolves eating a sheep. So back then, Microsoft still had like dark humor, which was good. But so the way you had to build this stuff was you had to have a SCSI cable, which at the time was these flat wire cable thingies, outside of your computers. One end was plugged into the RAID controller on one node, the other end on the other node, and the drives were plugged in the middle and had some power supply attached to them. And it still made sense because back then servers died frequently from hardware failure. So it made sense to start doing stuff like this. Very little later, the first disk arrays that had the RAID controller built into the disk array came out, and then you had the SCSI cables to normal hard drive controllers and not arrays. But the problem is to install Windows, it needed to be able to install the cluster-aware drivers. It needed to see the second RAID controller. But the OS was not allowed to run any IOs on that controller. So you had to start one node and stop it in the BIOS, then power up the other node, make sure the cluster-aware drivers were running, and then shut it down again. Boot this node now up into the BIOS, then run the other one, install the cluster-aware drivers over there, and once they were both installed, you could start up both nodes, and then they could figure out who owns which disk, and didn't try to write both at the same disk. Because if two servers write to the same disk at the same time, something very funny happens. The disk becomes corrupt. Because there's no locking or blocking on the disks. It's just who owns the disk can write. And there's one SCSI command that figures out who owns the disk, but that's it. That's the whole protection back then. So very fragile. The good side of this was you could actually build that with two laptops. There were external RAID controllers for laptops, PCIe cards, and you could demo this like in a conference. So you had two laptops with a flying hard drive with a power supply, and you could show this stuff at the thing. Horrible, but that was SQL 6.5 failover clustering in the beginning. And you have to fail a couple of times to make it better. So we failed a lot on this. I spent like months fixing these machines all over the place because people wanted the clustering because the servers failed a lot. Problem is, once they went to failover clustering on this was not even Windows NT 4 yet, or very early Windows NT 4. So this was not built to run this. But hey, people wanted it. So finding all these design flaws in SQL 6.5, and before Microsoft decided, hey, let's rewrite the whole thing. The biggest changes was on the Sybase version, a page was 2 kilobytes. They changed that to 8 kilobytes, which we still have today. And I know I spoke with people at Microsoft. They did run tests to increase the page size. It does not really improve performance or anything else. It makes storage a little bit more efficient if you have large amounts of data, but it makes it very inefficient if you have small amounts of data. Most people have small amounts of data, so 8 kilobytes it is. And the big difference is before SQL 7, scheduling was done in the operating system. Now scheduling is done within SQL Server, which in my opinion is super efficient, because what Microsoft came up with, the idea is that instead of context switching whenever the operating system thinks it's a good amount of time to do that, SQL Server switches context when it makes sense. So for example, if SQL is scanning a page and has one more record to go before it needs to finish the page, it will not yield. It will finish that one more record and then yield. If it has 50 more records to go on the page, it will yield when its time is up. So the code makes intelligence decisions at the point where it is, if it makes sense to yield or not. So for example, every time any thread inside SQL Server issues an IO, they immediately yield because they know they have to wait for the IO anyway, so let someone else do something. So whenever they need to read a page or write a page or something, they write it and then they yield because they know that the IO will take time anyway, so let other people do stuff. Yeah? So the scheduler inside SQL Server is fully aware what SQL is doing, and all the code inside SQL knows how to yield in the right place at the right time so that caches are not invalidated and have to be repopulated and all that. It's really good. So it's a lot of work that went into that. Another thing that came with SQL 7.0 is SQL Management Studio that we all hate and love today. Yeah, it came in 1998. It was its own program and not running inside of a shell of a development system that makes development very slow for itself. I don't know. I guess. A year after 7.0 appeared, Microsoft shipped an add-on for SQL Server that was basically free if you already owned SQL and you installed it on the same hardware. Plateau, a little thing that was called as OLAP services, which then became analysis services. They bought some company in Israel with the person that developed it, Amir. He's still with Microsoft, and he's now one of the super corporate vice presidents and speaks at every major event. Really funny guy. And it's still there and still has a very thing is. Next version, Microsoft didn't like version numbers anymore, so they decided to follow the trend. They came out with Windows 2000, so SQL had also became a new name and was called SQL Server 2000. Internally, it was still version 8.0, and from now on, we always have to specify the name and the version so we can understand things like database compatibility level, stuff like this. So version 8, codename Shiloh, is basically considered the first version of SQL that was enterprise ready, that people were willing to put business data on, like use it in production. I mean, sure, people use SQL 7.0 and before in production, but with 2000, the reputation became, this is actually good. Clustering became very popular in SQL 2000 because 2000 was the first version that allowed you to cluster on SAN storage. So that made it really safe. So it's no longer easy to corrupt the disk. It's still possible, don't get me wrong. There's some storage vendors that still had enough bugs in their operating system to corrupt terabytes of data. Don't worry. But it became much harder. It was no longer, if you don't press the right buttons during boot up of the system at the right time, your data is corrupt. It became to like, okay, the manufacturer made a mistake in their firmware, and that's why the data is corrupt problem. Yeah. Thing is, but the most important thing about SQL 2000 is that 3 years after it came out, a second version came out, also called SQL 2000, but instead of 32-bit, it was 64-bit. The problem is, for all of you that keep up with when CPUs were released, x64 was not invented yet. AMD hadn't outperformed Intel at the time, so this 64-bit version was based on Itanium 64-bit. What is Itanium? So, first of all, where's my Itanium? Here it is. So, what is Itanium? This is Itanium. That's an Itanium CPU. That's the power connector.
Quote of the day, where's my Itanium?
So the most important thing is about Itaniums is it scales. So there's another one. These things, each one cost $13,000 when they were new. And these were 256 gigabytes of memory. Also, almost $1 million. We're almost back to these pricings right now, but so in the year 2000, so 8 of these and 8 times this was the first SQL Server that we ran on Itanium on a database. That thing was about $500,000 euros or dollars at the time. So yes, I kept it as a souvenir because nothing runs on it. I still have a working one in the basement, and it's still faster than most current servers. So the difference is it was actual 64-bit. So a regular Xeon CPU, for example, has 8 32-bit registers. And if you need a 16-bit register, you have to give up one of the 32 bits and use it as 16-bit and so on. And if you need it for 8-bit, you this. Itaniums had 256 64-bit registers, 256 32-bit registers, 256 bit registers, so you don't dare to waste a full register on a bit value. It also had 256 floating point registers. And it could execute up to 7 instructions at the same time. So within one cycle, it could do 7 instructions. And that made it really, really fast. And it had a 64-bit address bus. Only 47 of the lanes were actually used. The other ones were not even getting out of the CPU, but that still is more memory than any machine ever had in existence. So the biggest machines ever built have 47 lanes. Is still more than enough. And it had very efficient interconnects to its neighbors. Each one had 24 megabytes of cache. And again, we are talking about the year 2000, 2003, 2004. And yeah, while a normal Xeon CPU was doing about 7 cycles to do some useful instruction, Itanium did about 0.7 cycles on average for one useful instruction. So I always compared it as like you try to haul around a lot of data in your computer. So let's buy a truck, but can we have a truck that runs like a race car? And that was what Itanium was. The problem was too few people had use for machines of that size. So 4 generations of SQL later, Itanium was scrapped and discontinued. You can still buy them today. So HP still sells them, but only with HP UX and some very high-end applications. Yeah, sad. Yes. Okay. 5 years later, after the initial release of SQL 2000, SQL 2005 came out, and a bunch of managers at Microsoft were fired at the same day. The problem was, if Microsoft does not release all 3 years, enterprise agreements make no sense, and clients cancel them. in large numbers, which put a really big financial dip into the sales numbers of SQL Server. So you will never ever see a delayed shipment of SQL Server again. uh, it was planned to have one in 2003, but it took till 2005. And even the release, the RTM version, was not complete. SQL 2005 was not complete till Service Pack 1. You remember database mirroring? Was not in 2005 RTM. It came with Service Pack 1. You could enable it in 2005, but it did not 100% work in things. So it took a while. Yeah. Thing is, the biggest problem with 2005 was that they finally finished the implementation of the SQL 95 standard, which means you could no longer use this star equal and equal star and star equal star join constructs when you were comparing values in in your where clause, because join conditions were placed in the where clause, not in the table selection. And that broke a lot of software. The problem is it prevented lots of people from moving from 2000 to 2005. So SQL 2000 ran way into the 2008, 2010 timeframe. And even then, lots of people got stuck on SQL 2008 because 2008 was the last one where you could put in a compatibility level to be compatible with that old syntax. And that was not the only syntax change, because that one would have been easy to find. You just search for these weird character combinations and replace them quickly. The problem is they also required brackets in certain places where they didn't require them before. And that broke a lot of code as well. So that was the thing. Yeah. And my thing I should share again, because I have some nice pictures. Yeah. Back in the days before the internet, you actually had to buy a boxed product. That's where the name comes from. It's a boxed product. And that's how they look like. And Microsoft had a very nice tradition that they usually created one gigantic box looking like the individual ones. And then everybody who worked on the product signed it. And in 2012, they had the brilliant idea to take that big box and shrink it again and give it to people. Unfortunately, there was no software. It was only foam inside. But still, it's a nice thing. So, and you can see that thing is, to give you a few numbers, in SQL 2000, the SQL team was less than 100 people. There's more than 4,000 signatures on that box. So it changed. Today, SQL is 8,000 people, the data platform. So, yeah. And here you can see a couple of these boxes. I've never found a box after 2016. I think by now there's only digital delivery. You can't buy a box. And if you would buy a box, I think the only thing you would find in there is like a sheet of paper telling you where to download it. Thing is, after 2005, Katmai came, SQL 2008. At that time, Microsoft also launched Azure SQL Database. Unbelievable. Codename CloudDB. I vividly remember giving a presentation. They gave it to me early before they released it and asked me about my opinion. And I was randomly in Redmond, so I said, hey, I can give you a presentation about it. And the presentation was titled, The Top 20 Reasons I Will Never Use It. And most of them are still there. Number one, to this day, you cannot have a backup of an Azure SQL database. You can have snapshots, And you can export your data, but you cannot have a transactional consistent backup, which is insane. But that's what it is. Thing is, after SQL 2008, SQL 2010, 2008 R2 to make it really hard to Google, codename Kilimanjaro, or after they came up with that name, everybody named it KJ because Kilimanjaro was way too long. By the way, if you haven't found the pattern, since 2000, the name is always a mountain where the launch party happened. So they already knew. So Shiloh is a mountain in Australia. So the whole 90 people were flown to Australia to play there. Liberty, not so much far away, but still, Yukon. Hey, it's in Canada. We're getting closer. Katmai, also in the North American continent. With Kilimanjaro, the 6,000 people at the time knew we're not going to fly there. The party will be somewhere else. Then they went back to the tradition Denali, and yeah, after that, the code names became rare and random. So Helsinki, Seattle, all these things. So there's a bunch of stuff going on, and I can read you the interwebs, what new features were there, but I rather do this in my personal view because it's much more entertaining. And you can, this is still online. You can just go there and to their website and figure all that out. So what kinds of SQL Server are there? And that's funny. So which CPUs were supported by SQL Server in time? x86 up to SQL 2012. Everything after that requires 64-bit x64. They dumped 32-bit, which is sad because 32-bit SQL was faster than 64-bit SQL when you had a database that was smaller than 2 gigabytes. And lots of databases are smaller than 2 gigabytes. Even if they were like 6, 7 gigabytes, the 32-bit version was faster because 64-bit is not faster than 32-bit. 64-bit is slower. It can just address more memory, so you can have more memory, which makes it faster. And you can move more data, but that took a while. That was not in the early 64-bit versions, actually only a 32-bit data bus. So to fetch a 64-bit value, they needed 2 memory cycles. Then we had Itanium for 4 versions from 2000 till 2008 R2. Nowadays, since 2019, you can run it on ARM. It's kind of a mixed emulation thing, so there's no native compiled one, but the code is the just-in-time compiler that translates the code works. So since 2019, and the very, very early versions were also running on MIPS and Alpha chips. Because back then, every Windows NT software had to be run on all these. By the way, there was a MIPS and an Alpha chip version of Office as well. Yeah, I still have the CDs somewhere. So yeah, so over time, SQL changed CPUs they support, and I'm pretty sure at some point something new will come along. I mean, Intel and AMD are cooking on 32-bit free 64-bit CPUs, which could reduce the number of transistors by a lot. So we'll see there. Supported operating system, also a wide range over the times. In the beginning, 32-bit Windows for server. Starting with 2005, there was an official desktop version of SQL Server for a while. And now you can just install the server version also on the desktop. It runs. It doesn't have all the features. Same goes for Linux. While it has all the T-SQL features, but it lacks some of the more operating system levels, which is fine. Almost nobody uses them anyway, so while doing porting, but it's important it's there. Since 2017, as Linux is there. And as I said, in 2014, they dropped 32-bit support, and I did not list the Itanium here extra because technically Windows Itanium is a different operating system, but thing is. So this one is an interesting one. It doesn't fit on a single page. Windows NT server versions, SQL Server version. Which one runs on which? And sometimes it's funny because, for example, SQL 2008 R2 requires Service Pack 3 to run on certain newer versions. So they have things. I haven't tested all the variations yet, but I will get there. So everything does space doesn't run. The ones with the dashes means it runs, but it's officially not supported. I haven't found anything where it would crash, but again, I ran some very basic stuff. I didn't torture the machines over a long time, but I'm getting there. So I'm completed with all the current operating systems and with all the current versions. I'm working my way back into the early days. I don't know why it makes things. It's sometimes this helps to figure out. So, for example, if you need to run SQL 2008 and SQL 2025, you need at least two operating system versions. You cannot put it on one. But if you need to run SQL 2012 to 2025, you can still run everything on Windows 2019. So if you just want to deal with one Windows version, that might be helpful. Some of them you have to put in the service packs because it's officially not supported unless you have that service pack, but that's fine. What are practical memory and core limits? That's an interesting one. 4.21, the practical core limit was 4 because you only had single core CPUs, and the biggest machine I could find back in the days was a 4-socket machine, which barely functioned, but it functioned. So Windows NT from day one was capable of running multi-threaded with multiple cores. It had some issues because it was not widely used on multiple cores. So there were some race conditions that crashed the server eventually 2 or 3 times a day. But okay, the rest of the day it was faster. So yes, memory went up. Then CPU core limits went up massively through the support of Itanium. You could have 256 cores in 2008. Partially in 2008, fully in 2008 R2, and up to 4 terabytes of memory. But since they killed it then, you were down to 1.5 terabytes, which then slowly went up to much more. And then the 792 with the Xeon-based Superdome that has 32 sockets with 28 cores each. And these machines can have 48 or 96 terabytes of memory. 46 is regular memory, and 96 is you have 1/4 regular memory, and the rest is then obtain persistent memory, which means it's insanely slow. You should not use that, but technically you could have it. And I know someone who has these machines in Austria, so they are around, but Intel stopped supporting them, so technically you can still have that, but you will run out of warranty soon. The next one is very red. Available support, which SQL versions are still supported. So SQL 2016 and 2012 lost support last year and 2 years ago. And in a month and 4 days, SQL 2016 will lose extended support, becomes end of life. Everything before that is end of life for a long time. 17 and 19 are still in extended support. The reason I don't make that green is because extended support means if there is a supercritical security issue, we will give you a patch. For everything else, you have a functional problem, we help you upgrade. That's basically extended support. And so every company I consult for is like, yeah, it's extended support means no support. We should be off that version. And so the versions you should run right now, you should running on 2022 and migrating to 2025. That's what it is. It's thing is, if you're still on 17 or 19, get off it. It's first of all, you have to be on the latest CU to be in extended support. If you're not on the latest CU, there's no support. They only will help you to get to the latest CU or get to the next version of SQL. Yes. Again, that helps. Every time something comes out, I immediately jot down the dates, so I know it, and the countdown starts ticking. Yeah. I mean, 25 is good for almost another 10 years, but yeah. Yes. Editions of SQL Server, that's fun. So we all know standard and enterprise, but there's also a web edition, which could be used from internet service providers to give you a database running SQL Server and the web. Workgroup edition, data center edition. That was a funny one that existed in SQL 2008 R2, the only version that had a data center edition. Microsoft had a brilliant idea. If you have a big server, let's make SQL more expensive. Data Center Edition did not have any additional features over Enterprise. The only difference was if you had more than 8 sockets, so more than 8 CPUs, not cores, CPUs, you needed Data Center Edition. The difference was regular Enterprise was about $12,000, the core license at the time. Data Center was $65,000. I do not know a single person that was willing to pay that. So it was in 2008 R2, and that's it. Hyperscale came in the cloud, Azure SQL Database, Azure SQL Database Serverless, Azure Managed Instance, SQL Server Edge was a big thing a couple of years ago. Haven't heard much about it since. Big Data Cluster, another Cluster F, was released in one version and deprecated in the exact same version. Funny idea. Microsoft thought, hey, let's add some open source software to SQL Server and try to sell it. Nobody wanted to buy open source. I don't know why. Parallel Data Warehouse, a brilliant software. Unfortunately, you could only buy it with 2 types of hardware that were both crap. Microsoft had the brilliant idea. You can't buy that software. You have to buy it with the hardware, and you could not install it on your own hardware. And they found 2 vendors that must have had a look in the inventory and says, hey, what's all the old crap we want to sell? Let's put that together into the appliance. It was horrible. To give you an idea, at that time, SSDs already existed, and they built it with spinning disks. Why would you build an appliance with spinning disks? An appliance that costs millions. Yeah, if it's millions or 1,300,000, nobody cares. Yeah. Developer Enterprise since 2025. Developer Standard, very important. Desktop, no longer available, was basically the predecessor of the developer version. SQL Server CE, which ran on these little Windows phones. SQL Server Embedded, if you run Windows Embedded, you could run SQL Server Embedded on that. It's basically thing is, and SQL in Fabric, the latest edition of SQL Server that has functionality. Code names. Yep, we went through them in the whole thing here. The one in one nice little list. Thing is, then special code names, arrays for big data cluster. Socrates, Babylon, Hackathon was in-memory OLTP. Apollo was column store. Juno was SQL Server Data Tools, which is the SQL project in Visual Studio or in VS Code. Rosetta was reporting services. Starfighter was enterprise manager, which was the thing before SQL Management Studio. And Starfighter 2 was SQL Server agent, because the very early versions of SQL Server did not have an agent. Yeah. Secure. Plato was OLAP, Picasso analysis services, Blue was report designer, Laguna was the mobile edition, DaVinci was the database design and query tools, and Crescent was Power View, stuff that existed. So this was the official history. It's old, bunch of versions, lots of features came, but let's see how I saw it. So this is my foot. That's how I do selfies. I put my foot in the picture. And this is a tombstone. So Microsoft has this little graveyard in front of Building 16 in campus in Redmond. There's hundreds of them. Whenever a product is end of life, it gets a tombstone there. So we can all remember it, but we never ever have to deal with it again. So this is the last SQL Server, the SQL Server that I never worked with, version 4.2, which was only available on OS 2. And yeah, it's there, and I visited its grave and paid my respects. SQL 4.2a is the first one I used. I used it, software written in Visual C++ 2.0, 16-bit, on Windows 3.11 using 16-bit ODBC, which becomes important. Best new feature in 4.21a. SQL Server could handle more data than DBase 4. So the problem was the customer gave us an estimate that over the lifetime of the software, which was estimated for about 10 years, they would have 300,000 records total. 10 years, 300,000 records. Problem is, in the first month of our software running, they had 500,000 records. So we needed a bigger database fast. And since, for whatever reason, we used ODBC to talk to DBase, we needed a replacement that could support ODBC, and SQL was the only thing we could find. We've never worked with SQL before. We've never installed it before. We decided that's what's going to save us, and luckily it worked. So that was the best new feature. It was an in-place replacement for DB4, DBase 4, which is true. Many, many years after that, Fox Pro, which is basically Microsoft's version of DBase, could use its own engine or SQL Server as the engine. So you could choose. So I developed several products in Fox Pro front end with SQL as the back end. Worked just fine. Worst new feature, Microsoft was not yet really good in handling the 3264-bit. So while Windows 95, when we upgraded the software from 16-bit to 32-bit on Windows 95, because we immediately wanted to do that because programming was so much easier in 32-bit than 16-bit. Windows 95 shipped only with 16-bit ODBC, and 32-bit software could not use 16-bit ODBC. So while the software recompiled fine under Windows 95 and SQL was still 32-bit as before, we could no longer access SQL Server from Windows 95. And back then, I had no connections to Microsoft, but I've heard that there's something called Microsoft support. So we found a company that had a contract with Microsoft and paid them a ton of money to open a case with Microsoft. That Microsoft, on the day when we found our own solution, because we found the 32-bit ODBC driver somewhere on the interwebs to download, the same day Microsoft returned an email to us closing the case with, unfortunately, there is no way to do it. But luckily we found our own solution. And so this was my first experience with Microsoft support, and some things never change. Let's put it this way. Microsoft support can be good if you get to the right people. If you don't get to the right people, it's a nightmare. SQL 6, best new feature, log shipping, was introduced in SQL 6.0, and I use it till today. It was made convenient in SQL 2000, but it was already there in 6.0. And the feature set was slightly improved in between 6.0 and 2000, like tiny little things. But it basically still works like day one, and it works and it does what it needs to do, and it never fails. I mean, it fails when you have corrupt log files, but if you don't, it doesn't fail. Thing is, worst new feature, replication. Replication was introduced in 6.0. God, this could be a 6 to 10 hour rant now. My problem with replication is mainly the name. It's called transactional replication. The problem is it's not transactional or transactional consistent. It doesn't do two-phase commit. It is a replication between three players: the publisher, the distributor, and the subscriber. But nowhere is a distributed transaction. That means every time you reboot or restart one of the three, there's a possibility to lose or duplicate records. And it happens. Every time one of these three machines reboots or restarts the service, so every time you patch it, every time you restart it for whatever reason, every time you lose power, there's a chance of you losing data in the replication process. You will not lose it on the source, but you will lose it on the way to the subscriber. We used it in large scale, and about every 300 million records, we had a missing one, which if you deal with financial data, that's not a good thing. Yeah. So, and this was never fixed to this day. The problem is later, Microsoft piled on other features on top of replication, and you will see them listed here as well. Change data capture uses the exact same technology as replication. That means data capture is not guaranteed to have all your data. How many people are using change data capture to load the data warehouses in financial applications? You are playing with prison time in some countries. In other countries, it's just a fine, but not a good thing. So SQL 6.0, horrible feature, replication. 6.5, the last version using shared code with Sybase SQL Server. Yep. Best new feature, failover clustering. Worst new feature, failover clustering. I think I explained it before. While the concept was great, the implementation in 6.5 with the sketchy SCSI cable outside the servers and free floating hard drives between servers. No. The next one, I have to thank Mr. David Klee for providing the image. The best new feature in SQL 7 was Unicode support, which enables that you can now create a database that has the name poop emoji, and then you can create a dump device that has the name toilet, and you can back up poop to the toilet. And yes, I do rename sometimes development databases to poop emojis because some developers deserve it.
I
But
aim to
having the
please with my
ability to,
demos.
sorry, but I had to retype it because you gave me a screenshot with black, and that's not good. So I had to recreate it, but yes, it's just awesome. It's just a new
The
feature. First
mind
new
of David
feature.
Clay.
First new feature in SQL 7, linked servers. Should they have ever been invented? No. Should they have ever been implemented? No. The amount of security leaks, the amount of slowdown, the amount of unnecessary moving data, the amount of problems, the amount of sleepless nights that linked server created in my life should never have been invented. Yeah? Is it used? A lot. I think the biggest company I've ever found was over 6,000 linked servers. They had over 20,000 databases, so they had less than one linked server per database, which is actually good. The highest number of linked servers I've ever created was 700 on a single instance. On purpose. No, it was my management instance, and I had a linked server to each machine that I managed and used the linked servers to talk to them because security only allowed me to use 1433 port and nothing else. So I needed a way to communicate with my servers, and I used linked servers. I never moved data across them. I only executed stored procedures on the other side through the linked servers. But it took a while. That problem was after about reaching 500 or so, I could not initiate my log backups through them anymore because it took longer to loop through them than I wanted to do log backups per minute. So it took more than 5 minutes to go to 600 linked servers, open them, and send a stored procedure through than it took to actually take the backups. So fun things. SQL 2000, best new feature, support for Itanium. Back then, it saved the company that I worked for. It saved my work. It made things so easy and scaled SQL through the roof. SQL 2000 was the first one I really worked with large systems. We went from 64 gigabyte 32-bit system, which used these advanced window extensions for Windows where you could have more than 4 gigabytes of memory with 4 CPUs with 4 cores each, so 16 cores. We moved to 16-core Itanium machines with 256 gigabytes of RAM, and all our problems went away. A year later, we moved to a Superdome with 64 cores and 2 terabytes of memory, and our problems were still away. And then we moved to 256 with 4 terabytes of memory, and that ran us way into the 2010s. In 2011, I then, for the same company, delivered the third iteration of infrastructure, which nowadays runs on regular Xeons, but uses a scaled out database model instead of a monolith. So instead of using one gigantic system, I found a way to distribute the database across multiple servers without sharing data. So each database is independent from the other one. And customers can move from one server to another. It's a thing. Worst new feature in SQL 2000, XML support. Hundreds of hours of discussing with developers why it's a stupid idea to use a end text column and put megabytes and megabytes of XML in there. Again, helpful if used correctly, completely not helpful to store data. XML was never designed to store data. XML was designed to exchange data between systems. And that's where it's really good at. And that's what it was supposed to be used for. But unfortunately, people found a way to store XML in SQL Server, and then Microsoft made the stupid mistake to create an XML data type and they repeated the mistake in 2025 by creating a JSON data type. Same problem. Best feature in SQL 2005, from my opinion, database mirroring. It started a journey to zero data loss with SQL Server. So database mirroring had the high performance mode, which was async, where the primary committed immediately, and then asynchronously moved the data to the secondary, which was good for long distance and was faster than the synchronous one, where the transaction was received on the primary, sent to the mirror, executed on both sides, and then once both sides were finished, it was committed back to the thing. The reason why I'm saying is begin the journey, we very quickly realized that, the high safety mode guarantees you no data loss as long as the primary dies first. The problem is both database mirroring and later on, always on, if the secondary dies, the primary waits 10 seconds for the secondary to come back, and if not, it continues without the secondary. Basically, removing your second copy of the data, basically removing your zero data loss. Because what if the primary now takes a couple of transactions and dies then? You don't have a second copy. So we will come back to that in 12 years from now in the timeline. No, not that today is going to take 12 years. Worst new feature in 2005, CLR data types, not CLR stored procedures. CLR stored procedures, good idea. CLR data types. While they worked great, there was no way of you could replace one. So if you found a bug in your data type and you fixed the bug, there was no way you could swap out the data type. Nope. The only way was to create a new column with the new data type that had to have a different name and then copy everything over. So while CLR data types was great, at the time we developed a data type that was called sports result that could take any type of sport and store the result. And then could you tell when you compare two values which one was winning? For example, when it's downhill skiing, the lower value wins, while when you play soccer or American football, the higher value wins. So that data type knew all that and could handle all that. Great. The problem is on the development system was not a problem. They wiped out the table, stored a new one. When we were ready to go to production, we were like, okay, so how are we doing an upgrade? And they're like, you can't do upgrades. We have to throw the data away and repopulate. I'm like, in production, we can't do that. We have terabytes of data. That would take days every time we do it. So CLR data types, while great in concept, practically unusable. Unless you are perfect and never write bad code, which no developer ever has. SQL 2008, moving on. Best new feature, backup compression. Saved millions of dollars over the years by making backups about a quarter of their original size. Super helpful. And saved a lot of money by not having to buy external third-party backup software that had that features for years. Worst new feature, resource governor and change data capture. Resource governor because my problem is my system runs out of resources all the time. So let's put more code that needs to be executed every time you need something from the system. So you're making the system slower to then reduce the speed and give it to someone else. Nope. Yeah. You have a performance problem, fix the performance problem. Don't put resource governor on it by not letting certain threads do certain things. Again, my personal opinion. Other people might have different ones. Change data capture. See rent from replication if you need to know why. It uses the same technology and therefore has incorrect data. SQL 2008 R2. My favorite feature is called create index with a smile. And chill, that command does not exist. But what happened in 2008 R2 is Microsoft finally allowed you to control more than 64 cores. And at the time we had 256 cores, which means 16 by 16. And you can't almost not see it here. On the real screen, you could see it really well. You could affinitize certain processes to certain CPUs. And you could draw a smiley face inside of Task Manager by affinitizing things while rebuilding your indexes. So you could create an index with a smile. We had too much time. There was a guy called Hank from the Netherlands. He had a 96 core CPU, which is more like a rectangle, and he figured out how to make text scroll through Task Manager. There's even a video driver that plays videos in Task Manager by utilizing the CPUs and using things. It's just black and white, but it still works. So create index with a smile. Very important feature in 2008 R2. The actual feature is we now support more than 64 cores. This picture we are in SQL 2008 R2. I have to honor my NDA from the days and cannot show you what's going on in this picture. So we will come to the picture later. But for now, I cannot tell you what's going on here. But it was in 2008 R2, but I can't tell you yet about it. We have to wait. Uh, this was in 2010. We have to wait. Worst new feature in 2008 R2 is Data Center Edition and Master Data Services. Data Center Edition is not so much a feature. It was a licensing model that quadrupled the price of SQL Server licensing for no reason. It did not survive 2008 R2. It disappeared and was replaced by a much worse licensing model in 2012. We'll get to them. Master Data Services, I don't know. I remember hilariously, I saw it, and we were discussing how we're dealing with master data at the time, and people might remember Lindsay Allen from the early days of SQL Server. She was the release manager, I think, of 2016 or 2017. Later on, but back then she was working for the SQL CAT team and was my contact. So when Microsoft announced master data services, I called her and asked her, "Hey, Lindsay, should I have a look at this? This sounds interesting." And she said, "Nope." Not for you. Don't use it. So if Microsoft tells you not to use something they just released, that should give you a hint. No, for the amount of master data we had, this thing used Excel as a front end to edit the data. No, yeah, whatever. 2012, best new feature, always on, which technically is not correct because always on had no space in 2012. It came in 14. Um, Again, a very important picture from the life of SQL Server. This was a couple of years before Always On was released. This guy wrote most of it. And these are the hands of Mike Steinige, and I'm holding the camera, technically doing something illegal because we were both under NDA, and taking pictures of NDA stuff is not the really thing is, but since the Microsoft person allowed us to take the picture, we explained to him what we needed in Always On. And since we did not have a whiteboard and the conference facility was not very keen of us using pens on their tablecloth, we resorted to using these sugar packages to use this as diagramming tools. Worked pretty well. So these were like the shared hard drives, and these were the nodes, and these were the switches, and the knives and forks were like network cables, and you could build pretty complex things. There's a 2-hour video of this whole discussion that we sent to Microsoft later. And that was how Microsoft learned how to build Always On over the years. And it became a pretty good feature. And yes, Always On was first spelled without the space and then with a space. And yes, marketing spent a lot of money to add that space. If we would have used that money, we could have had regex in 2012. Worst new feature in SQL 2012 is core-based licensing. Microsoft did it. Oracle did it for many years. Microsoft said we have to catch up and make everybody unhappy. Data warehouse licensing cost went from $7,000 to $2.3 million. Microsoft wishes. The company never stopped paying software assurance. The data warehouse is still licensed with $8,000. And yes, the data warehouse has more than 20 cores. Technically, there's a limit of 20 cores when you use the edition, the server licensing edition. My tip is ask Microsoft for that in writing, signed by someone who is authorized to sign contracts at Microsoft. You will never hear from them again because they don't want to sign it, because they know the moment someone has a signature with someone that can sign contracts, someone can go to court and they will lose. Because at the time where they did the licensing conversion, there were servers that were larger than 20 cores, and people were using it. So they were basically they were breaking their own enterprise agreement at the time. So they cannot do it. So up to 256 cores, you can use it. Technically, you could use it for more. The problem is, technically, Microsoft never released that version of SQL Server that could run on more than 256 cores at the time. I saw it, I played with it, but I never. Moving on, 2014, best new feature, Hackathon, also known in-memory OLTP. I love the nickname. By the way, the nickname of Always On was Hadron, like the Hadron Collider, the little experiment in Switzerland where they try to blow up the planet. And awesome. High availability, disaster recovery on Always On. One word, one thing. Always On at the time was a cluster feature from EMC in conjunction with Microsoft. There was already an Always On SQL Server, so there were two Always Ons. That's why they needed to edit the space. The Always On without the space is still the clustering, the distributed cluster solution. Well, this. Moving on. So here's the picture back. The two people in the background are not relevant. They were just co-workers, but this is genius number one, genius number two. These were the people that wrote in-memory OLTP. They tried to hire more people, but couldn't find anybody that understood what they were doing. So the whole thing was written by two people. That's why it took 6 years. That version on 2008 R2 could only support one data type, int. Nothing else, not small int, big int, int. We still could rewrite the session state database into in-memory OLTP and replace that server with that one. That was a reduction of 125 rack units in the data center and 23 kilowatts of power less. I mean, yes, today that's one graphics card, but back then that was a lot. That thing took 23 kilowatts of server. This was like 25, and this was like 800 watts or whatever. Yeah, two regular hard drives, lots of memory, but thing is, we needed a session state database and in-memory OLTP without the non-durable tables. Allowed us to do more transactions on this little guy than on a full-sized Superdome. Unbelievable. Yes, we ran that on 2008 in beta, on 2008 R2 in beta, and 2012 in beta, and then upgraded it to the release version in 2014. Hey, you do what you need to do is just imagine the number of licenses we saved. This was like a 6-core or something machine compared to a 256 core doing the same work. Unbelievable. Worst new feature, automatic soft NUMA partitioning. Why? If you need soft NUMA, let me configure it. Don't do it automatically in a way that makes no sense. The problem is if you have a CPU that has more than a certain amount of cores, Microsoft now breaks it into soft NUMA nodes, which might or might not be a good idea, which is fine. I get it. The problem is, let me decide how big the NUMA nodes are. Don't do it yourself. The problem, what you can end up with is that you have NUMA nodes with sizes. So one NUMA node might be 10 cores, the other one might be 12 cores. Where I've seen even odd numbers of cores in a NUMA node, which not a good idea. Anyway, 2016 best new features. Again, something nobody besides me probably has ever heard about. NVDIM support for tail of the log.
I did a bunch of testing on it. It was amazing.
Yep. So it is what it sounds like. So it's a memory module with an attached battery. So What it allows you is basically you have memory that doesn't lose its content when the server gets rebooted or powered off. So what that means is if you put the log buffer in there, you don't have to commit it to disk before committing the transaction back to your client. And yes, you can take that memory module out of one server and put it in another server and then start SQL on the other side and finish the transaction and commit them to disk. Would I ever want to do this in a production environment? No. Did we do it in our test environments? Yes, because everybody needed to know how to do it in theory. Because if we ever have to do it, someone has to. What if a server blows up, but we might know that the data is still on that little DIMM? We might pull it out and put it into the DR machine and then see what happens. Very interesting times. To give you an idea, on a regular SAN, on the fastest SANs you can buy today, not back then, you can do about 3,800 log writes per second. It's limited by network latency. You need to get the data onto the cable to the SAN. SANs are still measured in milliseconds. NVMe drives that you can direct attach, you can get to about 12,000 log writes per second because instead of milliseconds, they are measured in microseconds. Not nanoseconds like memory, but things. But if you then combine an NVMe disk with an NVDIMM, you can do way north of 100,000 log writes per second. That means you can do way over 1 million single row inserts per second on a single machine. And on a single machine, I mean something with like 16 cores or so. You don't need a big box to do that. You can, if you combine it with in-memory OLTP, you can go really crazy. Yeah. So that's it. It has a little drawback. First of all, the largest one I've ever found was 16 gigabytes. Most of them were like 8 gigabytes. And usually they are one performance step behind your normal DRAM. That means the moment you plug that in, all your DRAMs get clocked slower than it has to be. So you're paying some price on your overall response time, but therefore, so I would not put that in a read intense application that doesn't need it. So I wouldn't put it in every machine. I only put it in a machine where I need a lot of writes, and writes need to be committed very quickly. Logging servers, servers that capture events or something, lots of data streams that are coming in. Worst new feature, stretch database and dynamic data masking. We have two winners because two features that are useless, completely useless. Stretch database was useless because it needed an insane expensive service in Microsoft's cloud to run. So that basically your archive database, which should save you money, costs you more than your production database. And the way they implemented it, you still needed the space on your production environment. Because if you had to make, every time you needed to make a change of the schema, you had to bring all data back, make the schema change, and then archive it out again. And they charged you for bringing your data back on top of the charges that were already expensive. So stretch database, it's now removed from the product. 2025 doesn't have it anymore. It would have been great if you could do it on-prem, but Microsoft never wanted to give us the bits for that, so it became dynamic data masking. You can read it in the internals book, how to break it in real time with any data type. It doesn't mask the data. It's a convenience feature. It's not a security feature. The problem is they mask the data in the select layer of the query. That means in the join layer of the query, you can join to the unmasked data. So you take your table with your masked column, you have a second table that has every possible value in it, which you can create on the fly in every query, and join it, and you get the real data. Complete useless feature. Doesn't need any security. The moment you can read the masked data, you can unmask it yourself. We told Microsoft before it was released. Nope. Till this day, thing is, it took me 4 years to get them to remove the example on books online where they used credit card information as a demo, as an example. So to not do that, because that's actually like really dangerous if people do that. If they do it with an email address or something, it's bad enough. But if you do it with credit card information or other personal identifiable information like social security number, so it's horrible. SQL 2017, best new feature, create availability group. No, that's old. But with required synchronized secondary to commit equals a number. You remember in 2005 that I reported a bug to Microsoft? If the secondary dies first, you don't have zero data loss. That fixes it. You can now say that, hey, if I have a secondary, both need to commit. If both do not commit, stop taking transactions. That means if the secondary dies first, your primary stops taking requests from the clients and stops committing transactions. Is it a good idea to have two servers in your primary and DR data center and then enable that feature? No, you should have at least three and set it to two. So every time a customer has the real requirement for zero data loss, my solution is 3 data centers, 1 replica in each, and 2 of them must commit. And all 3 do synchronous replication. And therefore, normally all 3 commit. If one fails, the other 2 can continue to work. And if something then happens, I guaranteed have the data in 2 data centers and can assume that I will not lose the data. I'm still doing log backups and I'm still doing all the other jazz, but that's a really good feature in 2017. Hey, and it only took 12 years to get it after reporting the bug. So, good. Worst new feature in 2017 is clusterless availability groups. Problem with them is they look fine. They look great. And then someone that doesn't understand availability groups fully, because they look like a regular availability group, issues a failover and your primary is dead. The moment you fail over a clusterless availability group, the machine you fail away from is gone. Clusterless availability groups are not an HA or DR feature. It's just a scale out feature. The problem is if you're looking at the metadata and you don't look close enough, you can't see the difference. And if you issue a failover instruction, it will corrupt your primary data. The data is still good on the secondary if it was synchronous, which normally in clusterless availability groups it's not, so you lose a little bit of data, but the majority stays fine. The problem is it takes you a lot of time to get the primary running again. Yep. SQL 2019, best new feature, support for PMEM, Intel Optane persistent memory. NVDIMMs needed that battery that scared the crap out of most people. And was a thing that needed to be replaced every 2 or 3 years because batteries have an issue with being charged all the time. So persistent memory is basically the same as an NVDIMM with 2 differences. It doesn't need a battery, and in contrast to a normal SSD, it has no wear leveling. So you can change the value a gazillion times, it will not wear out. Looks like a normal memory DIMM, but it's not. They are much bigger. So at the time, the largest sticks could have half a terabyte in one stick, and you could put a lot of sticks, usually 12 to 24, into a box. And as this awesome math and algebra and a little bit of calculus shows you, you can, if you have a database in a certain size, it can be way faster than your normal NVMe solution by a lot, almost more than 4x faster than a regular one. this is for table scans. So this is for data warehouses. In OLTP, I never found a practical use case for it. The big problem, like with every good idea, like Itanium before, Intel, the hardware manufacturer, decided to not to discontinue the product. So while it still exists, you can still buy it. They're not producing anymore. So at some point they will run out and you will not be able to handle warranty for you. And the latest CPU versions don't support it anymore. So you have to stick with older CPUs. I know someone who runs a 48 terabyte machine with it and is happy as a cucumber. They will run it on that box years after support has ended. They don't care. They bought many boxes. They put them in storage. Something happens. They take the next one till something happens that the OS or something doesn't work anymore. They will deal with security issues in some other matter. It solves their problem that they have. 48 terabytes will be enough for many, many years for them. They're happy.
We had a use case for one of these. We put the tail of the log on one, and it took this nightly ETL process at a big logistics company from 2.5 hours to 8 minutes.
Yeah. If your NVDIM is not big enough, then that's the next possible way of doing it. I always could find a way with NVDIMs making it run. So I'm good.
We couldn't make it highly available just because of the speed in the interconnects.
Yeah, because
it was one of those systems where if something pooped out and died, they could just redo it on a different machine, and that was their failover mechanism. So it worked.
Like data warehouses. My solution for data warehouses is I load both sides. I don't load one side and move it to the other. I run the process on both sides and occasionally compare. But thing is, worst new feature in 2019, big data cluster. Microsoft understood how bad it is. They deprecated it the day after they released it. It's no longer in the product. Goodbye. Basically, Microsoft had this brilliant idea. Hey, what if we bundle open source software with SQL Server and then charge people per core for the open source? Like, what? And also, from the time they had the idea till they finally released it, so much time moved on that nobody was using that open source anymore. It was open source people moved on to the next shiny tool. So yeah, it was an idea to combine NoSQL and SQL into one product, and it failed miserably. SQL 2022 best new feature is not distinct from the most important 4 words ever written in SQL Server. You ever had to compare 2 columns that had possible null values for like a data warehouse load process or comparing or doing something? You had to put an or statement into the compare because that was the only thing, because you had to, is the value the same as the other value, or is one of them null, or are both of them null? You had to test all 3 cases. Is not distinct from does that for you. It basically means value equals value, it's true. Equal value equal not equals value, it's false. Value on one side, null on the other side is false. The other way around is false. Both sides null, it's true again. And that's all people needed for 20 or 30 years, and that finally delivered it. Also love the feature greatest and least, which is min and max. Problem is they couldn't use min and max because they already exist as aggregating functions. And you can combine a min and max, the greatest and latest, with an aggregate max min, and that would confuse the parser when they would both be called min and max. So yeah, so greatest and latest it is. Still makes writing code again much more efficient because you don't have to have these double nested inline if statement anymore. Worst new feature in SQL 2022, again, my opinion, other people have other opinions, support for Entra ID. You're putting your security into the internet? Sure. Have fun. That means your SQL Server is now 100% depending on the internet to run? No. The internet fails all the time. Every time freaking DNS has a problem, half the planet stops working. If you use Entra ID, your shit stops working. Yeah. From availability perspective, an absolute no-go. Security might be good, might not be good. In the end, Entra is Active Directory, just large scale. Active Directory works, but no. Nope. You need just no. So 2025. The verdict is not in yet because I haven't made up my decision, but we have a really good list of candidates who might be the best or worst feature. Best features first. Differential backups and full backups on availability groups. Replicas, finally. Only took, I don't know, 10 years to get there. Substring doesn't need the length anymore, so you can just get the rest of the string. Saves a lot and makes a lot of shit much faster. So that's good. And edit distance, which figures out how different two strings are by this edit method that programs use to give you, like, when you see the squiggly line in Word and you right click and it gives you options, it uses the top 10 based on edit distance from the dictionary. It's really good. It's really fast. I use it more and more to compare strings when they don't need to be perfect. So, for example, if I have like a drop down and people start typing the name of servers, I use edit distance to show them all possible servers. So if they have a single or double character typo, it will still show up in the list. Makes it awesome. Works really good. Is fast. So it's very high on my list of nice features. Thing is, worst new features in thing is change event streaming. Another version of replication. Yahoo. Vector data type. Don't get me wrong. The capabilities are awesome. What I've seen from performance so far, less awesome. When we're talking minutes for searching a million records, what went wrong? Regex. Yes, we waited for it for 30 years, and it's great that it's there, but again, the way it's implemented might be semi-optimal. And of course, my current favorite, SP invoke external REST endpoint. We're now using a database that works in microseconds and milliseconds, and we call web services that might take several seconds to reply. And then we're wondering why everything is slow. I'm just waiting for someone that puts that into like a query over a billion rows and then wonders why it never finishes because it does a billion REST requests out there or something. Yes, it is helpful, but the problem is it's supposed to deal with metadata. The problem is developers will misuse it for production data and large volume data. And there's no way from preventing them of doing that except for disabling the feature. And I already see, I saw something that someone was complaining that they use it to get PDF documents back into the database and it's not working the way they expect it to do. It's like, why? Moving on. Good. And since we now reached the end of this history, because we are basically now in the real time now, I've found some fun and I found a database anagram. And for everybody who does not know what Coale is, it's a town in Italy.
Okay, I was wondering there. I know it rang a bell, but I couldn't place it.
You have no idea how many people, when I put this as my background and my laptop, how many people thought I moved over to Oracle by not reading it correctly. Because, I mean, I assumed Joseph Font had something to do with it, but it's the second best anagram I found on all times, Oracle and Kawale. And I have the best one. The best anagram is the equation 11 plus 2 equals 12 plus 1. Why? Because if you write it in English, it's also an anagram.
That's the sign of someone that's had a little too much time.
Or knows how to Google. I The thing is, I did not come up with that. That came up on around the time of SQL 7.0. I installed a SQL Server for a pharmaceutical company, and I asked the person that worked with me, the employee there that hired me, I asked him for a password, and he gave me 11 plus 2 equals 12 plus 1. I'm like, what? And they're like, yeah, it's an anagram. It's the same letters and two, so that's how I remember it. It's a very long password, but and
I
that thing
like
stuck. I think it's hilarious.
I like
Other
that.
good honorable mentions of anagrams is dormitory, dirty room. Uh, New York Times, monkey's right. The Morse code, here come dots. By the way, here come dots in Morse code looks like this. And my favorite one recently, election results, lies, let's recount.
Yes.
So much for the fun at the end.
I
Uh,
like that. I like that.
yep. So, as you can see, some fun to end. Yeah, that's the history of SQL. 30 years in 2 hours. I think we
The
did
l-
good.
the
Not too
last
long.
piece that I want to make one comment on is that publicly Microsoft refers to the SQL Server ecosystem as Azure Data, even if it is your on-prem SQL Server. Took a
Yes.
little bit of wrapping my brain around, but I get it. It's a lot of the same code under the hood, no matter where it's at. So I,
Yes. I
I,
mean,
yeah,
all the SQL Server flavors, Azure Database,
managed instance.
Hyperscale,
Yeah,
uh, all these, even the data warehouse in Fabric and SQL in Fabric and all these, yeah, they all share common code to a degree. And then
yeah,
they all have their own little bits tagged on. Microsoft is really good in writing code so it works in one edition and doesn't work in the other edition. I mean, they learned with Standard and Enterprise Edition over 20 years doing that. And now they're using that, what they learned there, to have features enabled and disabled and all that. Um, yeah, I mean, there's use case for it. It's not like that the cloud makes no sense. It doesn't make sense for everybody.
yeah.
Cloud
Cloud.
solutions make sense for small companies. It-
Yeah,
yeah,
it's another tool for the toolbox. When it's the right tool for the job, it's
yeah,
great.
no.
When it's not,
I think I
don't use
mentioned
it.
this before. I have a friend who has a trucking company, has a bunch of people that work for him, and they need to exchange documents with the clients and with them. So what they're doing is they're picking up a car and delivering it somewhere else. Yeah, by loading it on a truck. So when they arrive, they immediately take pictures of the car all the way around to prove, okay, that scratch was already there. Yeah. And usually this is not like a car where a scratch doesn't matter. These are usually like very expensive cars that they're moving. So they load them up, they transport them before they go to sleep, they take pictures again, all that. And that needs, for years, he had a server in his office that made a lot of noise, cost a lot of money to maintain, cost a lot of money to operate and He needed to hire people because he's a truck driver. He's not an IT specialist. So he needed to hire someone constantly to provide email and file share capabilities. The moment he saw Office 365 with OneDrive, that server was blown up by an explosion. Yeah. After we moved all the data over there, he pays a couple of bucks every month for each one of the employees. It's a fraction of what it cost him to have that machine maintained, and is absolutely happy. Would that make sense if he has 10,000 trucks? No. Yeah. But with his size, family plus friends operation, like 10, 15 employees, makes total sense.
Yeah. Yeah, it's like for me, my production environment is up in the cloud because I don't have anything fancy. My test rig is 98% in my basement in a little mini data center I have that I maintain here because it
Yeah.
makes financial sense.
I do backups in the cloud.
Yeah.
For that, it makes sense. I
Mhm.
control the encryption keys. So good luck Google decrypting it, or AWS or Microsoft. I'm not telling you which one I'm using. I might use all three. Uh, yeah. I have the data there. It's super convenient. Do I still have this? Sure. And next week, it's going to be this one. And the week after this, it's going to be this one. And there's one at the bank, and there's one in a different building where I have 24/7 access. Yeah. Um, yeah. No, it's a necessary thing. And yes, but if you have 20,000 servers and you want to move them to the cloud, you're not saving money, you're not getting better service, you're not saving. Yeah. You have the problem with cloud is the costs are linear. It's a straight line up. You need twice as much service, you pay twice as much.
Yep.
Yes, you might get a couple percent rebate for a large volume or whatever. That's fine, but it's a straight line up. Yeah. With in-house, yeah, you have a steep line, but then it doesn't matter. You need a small OS team, you need a small data center team. Yeah, that's like $1 million or so. $1 million in cloud costs is nothing these days for an enterprise, a larger corporation. Yeah, mom and pop shop will never get $1 million. Yeah, unless they use AI. Then it might get there once AI starts charging the real cost of everything.
That's why.
Oh, that or the guy that
Go ahead.
accidentally left his credentials on an open GitHub repository. He managed to get to $1 million quickly.
It's for what I heard about AI. They are currently selling the service for $20 a month, but it's actually $15,000 that it actually costs them to run it per year. Yeah. So at some point, the venture capital money will run out, and then the real costs will kick in. Yeah. And it's the same thing. It's like get hooked on it, then is. Yeah. The reason I don't use Azure SQL DB, I I can't get the data out. Yes, I can export it into like comma separated files or something, but that would take hours. And during this time, you can't have the system running. Well, if I do a backup, I can keep running, take a log backup, and be finished. Yeah? And have to need like 5-10 minutes for the cut over. It's impossible. It's like 15 years now, and I can still not take a backup and restore it somewhere else. And there's no reason for it. There's absolutely no reason that this is not possible. Yeah, it's just the cloud provider does not want you to be able to take your data and get it somewhere else. If you put it in hyperscale, which by the way seems like it's becoming the standard that they're offering for everything, yeah, you can't take a backup from hyperscale either. Because you can't restore it because you don't have the distributed data store anywhere. So your backups will look completely different. We'll see how Fabric goes along, but I see no way. Currently, I love the concept of Fabric. The idea to have one place where all the data comes together and I can report from that is brilliant. The problem is having it with some company. I agree. It's very unlikely that Microsoft goes bankrupt, but it can happen. Yeah. Enron went bankrupt. Nobody thought that an oil company could ever go bankrupt. One day later, they did not exist, and they took several other companies with them. Arthur Andersen, no longer there.
Or if a government says people from outside the country can't get to this, which
Yeah.
that is a distinct,
Even that
you know,
is
it's a
another thing. Yeah.
non-zero,
So
it's a
I
non-zero
need a
thing.
way to be able to thing is, yeah. I mean, Europe is currently very nervous about that because something that we have to think about right now. And it's not that easy because we all got very used to convenient services in the cloud. Yeah. I started taking backups of my emails. I haven't done this in 20 years. Yeah. I mean, if I lose a couple of emails, who cares? Yeah? Hopefully not the one that I really need, but it's still, and I never thought that I have to deal with this again, ever. And it doesn't matter which one I choose. The problem is always the same. If it's not in my own thing, I might have an issue moving on. And some industries have that in their regulations that you have to be able to provide for each service. What happens if the service provider goes out of business? How will you continue your business? And it doesn't matter. You don't have to implement it, but they need a plan at least. It says, okay, you could say, hey, yeah, fine, emails. Our emails are gone. We start a new email account. We move the domain to another provider and start from scratch. We lose all our old emails, which is fine. Or we have a cached version of it in our Outlooks or whatever email client we use. It's fine. But with databases, it's much more complex because if if from one day to the next a cloud provider is gone, might it be through political reasons? Might it be through financial reasons? Might it be through something happens? Yeah, the wrong data center gets flooded. We were not that redundant as we thought we were, because it's is this. I read this article in some magazine a couple of weeks ago. It was a German one, so it's give me a few seconds to translate. It was basically, have you tested your data center for a cold start? Basically, turn everything off and can you turn it on? And do you know in which order you have to turn on things? Yeah. If you have any circular dependency in it,
Game
it
over.
stops working. I know I had it once many years ago. We used like availability groups, standard feature that you use. And we used availability groups across data centers for DR. And whenever we did a DR test, it worked just fine. We failed over, the system came back up on the other side, everybody was happy. Then we had a real DR situation. Oops. Yeah, it worked fine. The database failed over but didn't come online. Why didn't come online? Yeah, the problem is all databases failed over, including the database that had the internal DNS server information.
Oops.
So we needed to change the DNS to the other side
Whoops.
for the DNS to read its DNS configuration.
Oh.
In the DR tests, DNS were always running on both sides and no issue, no problem there. But when we had the actual DR and the whole data center was actually gone, DNS did not work. It's always DNS. Whenever something goes wrong, it's DNS. It's something you assume will be there and not. And this is so easily that you have that. It might be physical access that you badge your card that's going to some server somewhere. Are you sure that server is redundant and will work when you have an outage? I remember Facebook people standing in front of the data center not being able to get in till someone found the technology of a crowbar. Yeah, no, they knew how to fix it. They just couldn't get to the machines. Yeah. So the cold start or the same thing. I did it once. When we did these labs with Microsoft in Redmond, so a bunch of people from us went all the way to Redmond, brought our data, and Microsoft provided hundreds of servers, and we restored our environment and ran scalability tests with SQL for the next years. And when we had the opportunity, I spoke to my managers, can we have like 2 more days? And therefore we do an actual DR test. I'll hand them the hard drives and give them 8 hours because they say they can restore everything in 8 hours. Let's see. The first time we did it, it took about 10 hours, which is not bad for something that I was the only person that knew that this would happen, except from some people at Microsoft that because I gave them very specific instructions how to prepare the servers. Because we needed them, I needed them exactly in the same state as if the manufacturer would have shipped them. Because that's how our DR scripts were the idea. It wasn't actually a DR test because DR test was still like an automatic failover for us. It was like we called it last resort. What if both of our data centers are gone and we have to recover from the backups? And we got actually to test that. And someone boldly said we can do it in 8 hours, and he was not that wrong. 6 people did it in 10 hours. Yeah. Was it a secure environment when it came up? Hell no. Yeah. Every password was reset to the same password, and yeah, I mean, you have to go running, and we had a plan how to do it, and they actually had the document in digital form on the backups, so that was good. They would have preferred to have it in a printout because that's much easier to work with when you have only a single monitor. Uh, yep, no, and I was happy because the database is restored in about 4 hours. So I was done. Like it took me like 2 hours till I could start, till I had my machines, because they needed to restore Active Directory first and then install Windows and all that on the machines. But after about 2 hours, I could start installing SQL and start the restores. And it only took 4 hours to restore, I don't know how many 100 terabytes. Massive parallel. I had like 60 hard drives or so with me.
That would have been fun
And
to have watched.
we used, like the servers had these CD-ROM trays, the CD-ROM drives. So we used the CD-ROM drives, we pulled them out and put the USB hard drives on them and attached the USB drives to each server and restored on each server locally.
Next
It was
generation
faster
cup holder.
yeah. And the big databases, the giant one in the middle, we restored each backup file. We copied it from the USB drive to a server, but on a SAN drive that we mounted to each server. And then we took the 10 drives and moved them to one central machine and reattached the database.
Smart.
So, we had a plan how to do it.
Yeah.
It was just, we never thought that we would ever be able to test that because which company gives you a whole last resort? Because the plan of the last resort was we had a contract with the manufacturer of the server that within 24 hours, they have to be able to deliver us this many servers to that location. The location was an empty server room. We paid for the empty server room, but we did not have any equipment in there. So the idea was to bring the equipment there. And they had 24 hours to basically bring the equipment and screw it into the cabinets. And from there on, we had another 8 hours to get it running. Practically, we would start much earlier because once the first cabinet with servers is here, we could let's start with the domain controller regs first.
Yeah.
And start restoring from there.
Hmm.
They were the fastest to actually restore.
Or it should be pretty
The
small.
backup we did for the domain controllers was an image of the hard drive.
It's quick.
Took an
no
image every
compression.
day, and
Yep.
we just had the image with us, so they re-imaged the machine, and it just booted up and was ready to go. Because we have no idea how to back up an Active Directory so that we can restore it somewhere.
Yeah.
So let's take an image of the hard drive every day.
Smart.
And that imaging tool worked through the RAID controller. So you basically plugged in a third disk. It took the backup on the third disk, and it pulled the disk out.
Do you remember the name of that software? That's slick.
It's HP.
It's one of HP's. Okay.
Back then it was a P600 or P800 controller. They don't exist anymore.
Interesting.
Yeah.
That's
Took them a while. The feature is basically that you can have a triple RAID one.
It makes sense.
No, it's a little bit of software. For a RAID controller, this is an easy job. Make another copy.
Yeah.
It's what they do all day long.
That's cool.
So, yeah.
Awesome. Well, thank you everybody for sticking around. If you're watching this after the fact, again, don't hesitate to reach out. We'd love nerdy topics like this. Next month, TG will be back for, I believe this is Extreme Restores.
Extreme backup and restores, like cases that are out of the ordinary. When you have to do things that require special handling, like very large backups or very frequent backups, all the stuff that doesn't work normal. I don't expect it to be that long. That will probably be a normal 1 hour session, but it will have. I already have 3 cases. I might find another 1 or 2 that are worth in that topic. It's what you have to do is, if your normal backup procedures that work for 99.99% of all databases don't work for that one. And we all have that one somewhere.
Guaranteed.
Maybe we don't know that we have it, which is bad, but if we know, we know why it's there.
Yeah. So we will have that next month, and we will also have Edwin Sarmiento with a new session. So stay tuned on that. I'm going to be getting that posted and scheduled here in the next couple of weeks. So thank you all very much, and thanks TG for presenting yet another amazing session. And we'll see you all next month.
Yeah.